Hello and welcome to the webinar. My name is Shreya and I'll be your host for the webinar today. Our webinar today focuses mainly on iOS 8 and Android L and its impact on enterprise mobility. We will take you through the new developments while sharing use cases so that you gain a clear picture of the implications in your industry or vertical. Our webinars are designed to gain insights into the field of enterprise mobility, which today has become an indispensable part of the enterprise ecosystem. Endeavour Software Technologies is a mobility-focused organization with more than 300 mobility experts and 12 plus years of experience. We have provided mobility solutions to several Fortune 100 companies across the globe and have enabled them leverage the power of mobility. In today's webinar, we will have a 45 to 50 minute session followed by a 15 minutes question and answer round. Please feel free to raise any question in between the presentation by typing them in the questions window in your GoToWebinar console. The webinar is being recorded for your convenience and the recordings will be made available on techendeavour.com/webinar. Today we have Tom Parrish, mobile strategist and thought leader, and our technology panelists. Now I would like to invite Tom to take us through the webinar today. Over to you, Tom.
Thank you so much for the introduction, and a special thanks to each of you online right now. I know your time is valuable, so I'll get right to it. June 2014 was a huge month for the mobile technology industry, and both Apple and Google are having their annual developers conference at that time. Most of you know that, of course. That's why you're on the call. Apple's Worldwide Development Conference kicked off with a keynote on June 2nd, and Google I/O keynote took place on the morning of June 25th. Both events were attended by approximately 5,000 developers, and a whole lot of others streamed the events or watched on live blogs. I did both those. If the rivalry between Google and Apple was a war, then each of the companies' annual developer conference would have been the frontline battle. You could see that in everything that was being said. Senior figures from both companies were attempting to outflank each other with shiny new products and software updates and lofty displays of self-congratulations. It was pretty interesting. So let's get to the agenda. What we're going to do basically is go through a comparison of Google I/O and what was said at Apple's Worldwide Developers Conference. So we're going to compare these two kits that they've come up with, both in the area of fitness and health, the area of cloud storage, G Drive versus iCloud, and Android TV versus Apple TV. We'll be talking a lot about what this actually means from a practical perspective and how it applies to the enterprise. The key highlight from the Google I/O event included the Android One program, which is a partnership with Micromax to launch a less than $100 phone for developing markets. Also unveiling of the Android L, the new version of their OS, Android Wear devices, example the Samsung Gear and LG Watch, the Android for TV and car, and the Android for work, which allows you to separate your work data from your personal data. Over on the right-hand side there, of course, is Apple's key points at their worldwide conference. While some of the major announcements from Apple included revealing what's new in iOS 8 and OS X Yosemite, the new kits like the Health and HomeKits, app extensibility, which allows for widget creation and third-party keyboards, family sharing, which allows sharing iTunes purchases with up to 6 people, and a revamped App Store, and the introduction of a new programming language called Swift. We'll talk about some of these developments as we move through the upcoming slides. So let's dig into the HealthKit coming from Apple's iOS 8. Now just follow along with me here. The key points are on the slide, but I'm going to talk about them a little bit. The basic point is with iOS 8, all the iOS devices would have a new app called Health, which gives users easy to read dashboard comprising users' health and fitness data. Think of HealthKit as a framework. It enables apps to store and retrieve health information. With this, apps save users' health data into a centralized, secure health store, or a database, essentially, which can be made available to the user via health and other apps. With this channel, apps access health data from other apps via the health store. Obviously, all this sharing across apps is as a configuration done by user, governing his privacy. HealthKit enables apps to request users permission to save the data collected by the app to the health store with fine-grained control over each type of data. An example, a user can choose to only share his blood pressure with health store, but many may not want to share any of their sensitive data. The same rule is applicable for reading data as well. Example, the user can let an app to read his blood sugar level from health store, which might have been saved by some other app, but may not want to read pulse or heart rate that came from other apps. So HealthKit also enables apps to configure itself to be notified when there is a data change happening at health store that a listener app is interested in. In other words, any other app might have been triggered or saved by other apps, depending on what was set up. An example would be an app can subscribe to get notified when there is a change or a surge in blood pressure. HealthKit also facilitates apps to retrieve statistics from Health Store to access cumulative health data, or an average, as well as discrete min, max, and average. Statistics can be asked across all health data or from one particular source. Now, Google Fit. Google Fit is an open platform that lets users control their fitness data and provide complete picture of a user's fitness. Google Fit lets developers build smarter applications and encourage manufacturers to focus on creating amazing wearable devices. Eventually, it blends the data from multiple sources of application and the devices. Google Fit for developers enables an application to take advantage of Discover sensors, which is a simple way to access sensor data received from various sources of the connected apps and external devices that access through the sensors APIs. It also helps to collect activity data using Google Fit recording APIs. And another amazing feature is to keep track of fitness data. All the above are new additions to Android L. By introducing these features, Google will compete with its rivals. And for instance, Samsung unveiled their health tracking platform, SAMI, that is the Samsung Architecture for Multimodal Interactions, in May, which is a very similar framework that helps to manage health and fitness data. Okay, now that we understand what Google Fit is and Apple's HealthKit, let's go around the clock here. You can follow with me as I talk about the possibilities that are available now with regards to healthcare in these platforms. Using the Health app, a user can check the cohesive view of his health and fitness data collected from different apps. He can also configure what kind of health data can be shared with the apps, which is nice. In Android, users can also view health data on their Android Wear watches, which is pretty cool. Number two, let's take an example of nutrition app. If you save the nutrition data, your calories that you consume during the day and what you eat and all that, into a health store, and you do this on a permission basis, you can access the current blood sugar level and pressure readings from Health Store to suggest up-to-date information with regards to your diet. What should you be eating next based on what you have been eating? And in case in case the user exceeds his consumed calories or not taking enough of dairy or protein, the app can send a report with what you have consumed, in other words, to a nutritionist for his attention. A fitness app, for example, can save the fitness data, calories burnt, step counts, into a health store. Indeed, as permission involved, as permission is allowed, remember this is one of the key features. It can access the current weight and heart rate readings from Health Store and suggest an update with regards to training. In other words, if you're working closely with your training and you go into the gym and he says, hey, you haven't been putting in enough steps and walking here. Here's what you need to do today in the workout. So let's talk about the partner ecosystem that HealthKit and Google Fit are pulling together. Now, some of these names I would imagine you're familiar with. I mean, we all know Nike, and by this point, everyone's heard of Fitbit and the Mayo Clinic and companies like that. But this slide depicts the common and unique partners that HealthKit and Google Fit ecosystem are working with. And so I'm just going to mention a few more here that maybe you know. In addition to Nike, there's Runkeeper and Adidas, and they have fitness apps that are partnered in this program. And although Fitbit isn't an official partner to HealthKit, Apple has displayed its company's logo on the stage during the event, applied to work with Google Fit as well. MyFitnessPal, the largest digital health platform with 65 million users and an early partner of the Amazon Fire smartphone, says it's evaluating both platforms and looking forward to integrate with these frameworks. I want to talk more now about the comparison of HealthKit and Google Fit. You have probably noticed by now that both the platforms have tried to address some common use cases, though they diverge in their own special way. You have learned that a few of the features are common. For instance, centralized secure store for saving health data, which makes sense. Apps work in collaboration by sharing relevant health data with each other, and users can control what sort of health data they want to save in the health store or share with other apps, and what kind of health data the app can pull or read from the health store. Here are some obvious differences. Google Fit supports additional APIs. One is the application can discover sensors available for monitoring from different health parameters. And number two, the platform provides API access to health history of health and fitness data, which I think is pretty cool. HealthKit provides an additional API, though. With HealthKit, applications can ask for statistics of users' health data from Health Store to know users' cumulative health details and also subscribe to get notified on events. Think of it as health data alterations that an app might be interested in. Let's move on to iCloud Drive now. And this is obviously something we're probably all familiar with to some degree, whether you're using iCloud or Google Drive. But let's get on with the information that's relevant about updates to their Apple's cloud framework called the iCloud Drive as a cloud-based storage. Using iCloud Drive, users can safely and securely store all the presentations and spreadsheets and PDFs and images and any other kind of document in iCloud and access them from your Apple devices. Users can work on the same document from any iOS device or Mac and seamlessly sync the same version of the document across all the devices. They showed this during the event. It was pretty cool. The iCloud documents are automatically synced across all the registered iOS devices. Users can drag and drop files and documents into iCloud Drive from the Mac. This is if you're running Yosemite, or Windows 7 or later from iOS. Documents can be added using iCloud enabled apps. That's cool. So with these changes, iOS 8 has brought collaboration between the apps at a whole new level, and this is what they actually showed there that was so awe-inspiring. A document can be securely shared across the apps and edit it without having to manually import and export multiple versions of the doc, which is pretty cool. So for example, you can create a drawing in a sketching app, then open it in the Paint app to color it in. With iCloud document storage, data transfer happens automatically and securely. The operating system initiates and manages uploading and downloading of the data for the device attached to an iCloud account, of course, and iCloud data lives on Apple iCloud's iCloud data lives on iCloud servers, but the system maintains a local cache of data on each of the user's devices. This is where you get a little better performance. Local caching of iCloud data allows the user to continue working even when the network is unavailable. Yay! Such as when you turn on airplane mode. So you gotta like that. The iOS document architecture manages conflict resolution by nominating a winning file version, but apps can either accept the suggested version or specify a different one and handle explicit conflict resolutions with users' intervention if needed, which, that's going to happen periodically. The iCloud also serves to encrypt data prior to transit, and iCloud cloud servers continue to store the data in an encrypted format using secure tokens for authentication and ensuring security. Now let's move on to Google Drive. The Google Drive Android API uses the local device storage to create, edit, and open files and synchronizes with the server when the device is connected to the internet. If a user requests a file that isn't already cached on the device, the Drive service downloads the file next time when the device is connected with the network. That's great. The API automatically handles complex tasks such as offline access and synchronizing files, and this allows you to read and write files as if drives were on a local file system. The Drive Android API also significantly reduces the installed size of Drive-enabled apps. Because the API is part of Google Play services, the client library, you no longer need to compile your app using the Google API's client library for Java in order to access the Drive service. That's a really nice efficiency change there. Let's talk about resource metadata. It contains all details about a file or a folder, including the title, the meme type, and whether the file is editable, starred, or trashed. These are things we're familiar with. Building your own user interface for selecting or creating files is a thing of the past, okay? The Drive API includes activity builders for two of the most common user activities, opening and creating files. Another feature helps query builders, has to do with queries, to construct a query by joining together multiple parameters and filtering based on metadata. This allows you to easily display only relevant files, such as files shared with the user or files with a specific meme type. Okay, a little mid-webinar comparison here to see if you're listening. It's not a test, but kind of is. All right, let's do a summary. As discussed in the earlier slides, both iCloud Drive and Google Drive have transformed the way of constructing and managing data. They have simplified the way developers build applications that work now more seamlessly on all the mobile devices connected to the network. Some of the highlighted features include automatic sync, offline support, safe storage, and then the multiple devices thing, of course, that I mentioned. But additionally, Google Drive supports smart search, and I mentioned in the previous slide, meme type or shared files functionality. An inbuilt user interface for selecting or building your own user interface for selecting or creating files is a thing of the past. You used to have to always build that up as a custom way for every app. The Drive API includes activity builders for two of the most common user activities. Again, opening files and creating files. This is a big deal. Okay, now the cool stuff. Android TV. Are you an Android TV person or are you an Apple TV person? I guess we'll find out. I wish we could take a survey. Anyway, Google has taken the wraps off a new version of Android for the living room at today's Google I/O 2014 keynote. The Android TV, the successor to the ill-fated Google TV. Anybody have one of those? Android TV brings new interfaces to TVs and game consoles and set-up boxes and others to collaborate content at the center, which is pretty cool. It's aimed to create an interactive television experience by overlapping a 10-foot user interface on top of the existing television programming. Pretty interesting. Android TV supports watching video from multiple sources, such as Google Play, YouTube, Netflix, Hulu, and other, typical providers. For games, Android TV interacts with various gaming accessories, such as gamepad, joysticks, and provides personalized recommendations based on user viewing experiences. Voice search, voice cast are among few important flavors added in Android TV. And Android TV for developers extends applications to run on TV with some limited capabilities. Applications that use GPS, camera, microphone, near-field computing, telephone, these are all supported with this version. In this first phase, it's my understanding Google has partnered with Sony, Sharp, TP Vision to offer the platform and TVs planned for release this year, 2014, and next year, 2015, while Razer and Asus plan to release set-top boxes with a focus on gaming a little bit later this year. Software developers will be able to use the Android Software Development Kit, SDK, to optimize their apps to run on Android's TV. Now, HomeKit from Apple. Actually, this is one I'm personally really interested in and was excited to hear about. Just follow along with my story about it here. I have a number of really key points. They're all mentioned in the slide briefly, but I'll be talking about them in more detail. HomeKit is a new framework for iOS that brings rationality to home automation. Very much needed. Applications can leverage HomeKit to provide consistent user experience with home automation. If you've ever done anything with home automation, you know how sort of disparate and disconnected everything is from different manufacturers. HomeKit is a way of communicating with and controlling connected devices, in your home, and it enables you to discover devices in their home and configure them, and also create actions to control those devices. And users can group the actions together and trigger them using Siri, which ought to be pretty cool, with the Siri engine in the Apple SDK. Controlling home devices remotely is the highlight of HomeKit framework. At the home configured, all the home configured accessories and home information is managed by a centralized database and is available across all the applications. HomeKit enables Siri to communicate with these and identify these various devices, like I said. HomeKit respects the user privacy and security by enabling end-to-end encryption between iOS devices and the accessories. So HomeKit has the following components in the framework. Home Manager helps the user to add, remove homes, rooms, zones, and HomeKit accessories, and all these homes, rooms, are uniquely identified with a name so that Siri can interact with them. Services. Service represents the functionality of an accessory. It contains characteristics of the services. For instance, garage door opens, door locks, thermostats, IP camera controls, all the things that are needed for a particular service. Characteristics represent the state of the home device. In other words, for instance, the power state, is it on and off? Or the temperature, what amount of temperature is there? Characteristics provide data about the service like power state, lock state, brightness, current temperature, and all these different things. It makes sense. From a zone point of view, which is really nice, you can arbitrarily group these services into different rooms and for the different devices. So you might have like the basement area or the front door or the back door, and that's what I do for security at home. Services groups are arbitrarily grouping of services to control home services across various devices, microwaves, lamps, lights, and ovens, and things like that. And then action sets are collections of actions that are executed together. For instance, at night, lock the doors, close the garage, turn off the lights, and set the thermostat. A whole series of things. It's pretty cool. I'm really looking forward to that. Trigger, of course, would be actions that can be managed by triggers using timers. They can be repetitive, of course, and they're executed by iOS in the background. So all the triggers, service groups, and action sets and services and characteristics are uniquely named and therefore recognized by Siri. All right, so here's a summary of HomeKit. A typical HomeKit enables the app workflow to include a setup of the system by adding homes, rooms, and zones, to scan and look for all the accessories that are attached to the respective rooms. It also would allow and enable the user to check accessories characteristics and configure services and service groups. And finally, the app also facilitates user to set up an action set or sets of actions and triggers to help the user with easy interaction with home devices and hence provide a greater user experience. In other words, I'm going to leave the home, I'm going to drop the air conditioning, I'm going to lock the doors, I want notification that the garage door went down properly, things like that. Last but not least, all the user's home devices and data are stored in a centralized repository in a secure way, enabling multiple home apps to contribute and access the data to work collaboratively. Thank goodness. Since Siri identifies and interacts with all the home devices and actions, users can easily interact with the applications and provide a really cool interactive experience. It's about time, isn't it? All right, CloudKit. Apple already had iCloud technologies like the iCloud Drive and iCloud Photo Library and iCloud Core Data, but CloudKit is something new that was introduced at WWDC. And it's a framework. It provides a conduit for moving data between apps and Apple iCloud Server. CloudKit Storage is one of the iCloud technologies for managing structured data in iCloud and sharing that data among the users. Apple provides some server infrastructure, backup, and user accounts so that the developer can focus on building more powerful iCloud-enabled apps, which is really quite amazing. CloudKit enables apps to easily and securely store and efficiently retrieve the app data, like structured data in a database or assets from the iCloud. With CloudKit, the app developer has to design the data synchronization mechanism. That is, when to move the data from your app to iCloud, and from the iCloud to your app. Although the Cloud iKit provides facilities to keep app informed when changes occur, one must still fetch these changes explicitly. Because app decides when to fetch and save data, app is responsible for ensuring that the data is fetched at the right time in the right order. Okay? CloudKit provides useful queries to facilitate the user, to retrieve a slice of the larger sets of data saved in iCloud as per his preference, for instance, whenever it's needed. Thus, using queries, app can pull the updates from the iCloud server. CloudKit has the capacity to push updates to the client app whenever data update happens in the server. And this helps the app manage subscriptions or persistent queries and to be notified on data change happening at the server. And this is made possible by two things. The server runs the query in the background, and the server pushes the differences via Apple push notifications. CloudKit also has additional features with respect to the user accounts by giving them three things: a stable user identifier that is without revealing his Apple ID, it's changed, ability to store and retrieve metadata of the user, and discover other users of the app. Okay? CloudKit is best suited for enterprise apps, though, with huge public data owned by the enterprise, along with some user-specific data. A good example of this would be Salesforce. We're going to move along now to this new thing in iOS 8 called iBeacon technology. And if you hadn't heard about this, it's something you're definitely going to want to learn more on, because it's really quite fascinating. And again, I'm going to talk narratively about what iBeacon is about, and you can follow along on the key points here, but here's what we've got to say about this. The iOS iBeacon technology is advanced to include region monitoring based on BLE, Bluetooth enableability. Apps can register for Bluetooth regions, and apps can notify the app when users' devices into the regions. Okay, this enables apps to precisely locate the user in a much better way than a traditional location monitoring using GPS coordinates. Apps can leverage this feature to present relevant content actions based on the user's location. So, for instance, if you're in a shopping mall, or even in a big grocery store, you're going by the ketchup and they say, hey, the ketchup's on sale there. So anyway, with iBeacon, the app can even locate the proximity of the user from the developed beacon to gain access or control over the location. That's the whole point. Starting iOS 8, the app should request for user permission to track the user's location continuously, which is good, but this will all be done in the background, and the user can design these various functions based on user movements. For example, you can be identified when a nearby attraction is there, and notify the user when the user goes home, for instance. This information can be used to present relevant local notifications based on user location. As I mentioned, the grocery store app is one. Maybe you're going by your pharmacy, and your HealthKit knows that you need to be refilled, so it refills for you. It reminds you to drop by the pharmacy to get the refill. The app can also introduce visit monitoring. Apple has also introduced visit monitoring capabilities to iOS 8, which can monitor for destinations and even launch an app when a visit is detected. With this app, the user can track users' visited location coordinates along with the arrival time and departure. This enables the app to derive users' patterns and design to be prepared with appropriate content actions based on the content that's there. Apple has introduced indoor positioning in the Worldwide Conference in 2014. This addressed most of the indoor use cases, like directories for airports, venue maps for malls, some levels of interactivity, of course, where you could listen to commentary, for instance, if you're in a museum exhibit. This also includes location-centric features like the way of finding and navigating in areas. You ever get lost in a mall? That'd be nice. Finding friends you're looking for. iOS 8 MapKit framework is equipped with helper functions to enable indoor positioning and navigation. And this includes rendering floor map images and coordinate positions and spherical distortions, orientation, define and anchor points, and find out differences between 2 points. It's pretty cool. Indoor positioning is currently available for 3 venues in the United States, and Apple has announced there are going to be many more in the up-and-coming future. So more on the Apple side, let's talk about extensions. App extensions is a way where an app can supply custom functionality to specify areas of the system within the context of a user task. Okay, the system lists the extension in the relevant context, and then it initiates it when the user chooses it. Extensions an extension enables collaboration between an app and the transfer or file of data silently between the apps without compromising security. It's a pretty sophisticated interaction. There are 3 major features of extensions, and I think this will help you understand better what's going on. One is called Document Provider. It provides a document storage location that can be accessed by other apps. This extension allows other apps to access the documents managed by your app. Okay? Extension acts as an interface between the files that your app manages and the other apps on the user devices. It lets the other apps import or open the files, uploading and downloading them from your server as needed. Apps can also export or move their documents into your extension's shared container. Other apps can access these documents using Document Picker, using interface browsing through the Documents file system. Additionally, apps that are strongly associated with a specific type may benefit from creating a document provider for their documents. Here, the document provider acts as a local repository, okay, for a particular type of document, letting the user gather all those documents into one place. All right, so an example would be a PDF editor app can employ its own storage extension for storing PDF documents. Pretty cool. Thus, all other apps can leverage the PDF data storage provided by the app. And this would be more useful with the Document Picker, which enables sharing the files with PDF App Editor. Pretty cool, pretty cool. So another extension is called Today. All right, this provides a quick update, or it enables a brief task in the Today view of the Notification Center. Widgets or extensions of the Today's view provide a quick access to important information to the user. The user can even perform a quick task using the widgets. So an example is a to-do list app can provide a widget with the pending items with the ability to tick off each one of the tasks when it's done in the Today view. A nutrition app can provide a widget with calorie intake for the day, with the ability to add calories as the user consumes or foods and drink and things like that. Again, it's just a quicker way to just get stuff in without having to fiddle-faddle around or bring up your apps, different apps. Because the user interaction with widgets is quick and it's limited, you should design a simple, streamlined user interface that highlights the information users are interested in, okay? Not everything. In general, it's a good idea to limit the number of interactive items on a widget. So in particular, note that iOS widgets don't support keyboard entry. Because widgets don't allow keyboard entry, users need to be able to use the containing app to configure a widget's content and behavior. And then finally, custom actions. It's another extension. A custom extension helps users to transform content within the context of the app. So for example, an extension might help users edit an image in a document that they're viewing in a text editing app, and another type of action extension might let users view a selected item in a different way, such as viewing an image in a different format or reading text in a different language. Action extension is listed in the action area of the activity view controller that appears when the user taps in the share button. So after performing the operation, the resulting context or edited content is returned to the host. So here's an example. An app can publish an extension to edit an image, annotate, or sign functionality, which other apps can leverage using Action Menu in their app. Custom keyboard is another type of extension. It provides a custom keyboard that the user can choose in place of the system keyboard for all the apps on the device. That's new for Apple. And in addition to that, that app would, we're talking about being able to respond to taps and gestures and other inputs, which can get inserted into plain text as the input field. Okay, back to Google. We're going to talk about Android Wear. All right, Google entered the wearable market in 2013 and with its Glass product, which is available initially to explore more by invitation. I don't know, anybody out there get a chance to try one out? I've seen guys around Austin carrying them. It's pretty cool. But this year they've made it available to everyone, and Google Glass was not open to other OEMs. That's pretty interesting. But this year, Google has launched its second wearable product called Android Wear, which is a customized version of Google's Android operating system designed for smartwatches and other wearables. Android Wear will be open to all OEMs. Currently, most of the Android OEMs are part of this project, which is pretty cool. Let me provide some insights, though, of Android Wear, and so you can leverage and how you can leverage the wearable devices. How it works? Well, it works by pairing with mobile phones running Android version 4.3 and above. Android Wear will integrate with Google Now functionality and mobile notifications into a smart watch form factor. The success of wearable devices depends on the number of sensors it supports and the number of apps available on it. Android Wear, is eyeing on the success of these products as it supports many of the inbuilt sensors related to health and fitness. Android Wear is going to ride on the success of Android platform and a greater possibility of repeating success of Google Play. Motorola and LG have announced their devices, and that was quite a bit of a shock at the Google I/O launch that Samsung Gear Live was announced. They have this Tenzin-based watch called Gear 2. And LG G Watch also launched at the event. Google I/O attendees received one of these devices as a freebie and will be receiving a Moto 360 that will be released later this year. Wish I'd have been there. Would have liked to have gotten one of those. Possible use cases for these, we'll have to see, but they're certainly aiming also at the home automation market, digital identity, and various phone functions and fitness tracking. That's the big thing now. Now, how's Google going to move into the auto area, which we all know they've spent a lot of time focusing on? It's called Android Auto, and Android Auto was designed with safety in mind. With a simple and intuitive interface, it integrates steering wheel controls, powerful new voice actions, and it's designed to minimize distractions so you can stay focused on the road. Driven by Android, as it's called, you connect your phone to access all your music, contacts, and messages while keeping your eyes on the road. An interesting thing is both Apple and Google have unveiled plans to get their mobile operating systems going, usually found in phones and tablets, but now running in cars, right? But the first skirmish in what was likely to be a drawn-out battle will be about mapping and navigation, start out with. And we all know Google Maps is miles ahead of Apple Maps. Factor in Google's broader track record in automotive tech, including driverless cars and the promise of Google Glass, and you've got a very strong case for favoring it over Apple in the context for in-car supremacy. We'll see what happens, but I think they got a running start on this. All right, let's move now to Apple's mobile device management and mobile policies. MDM, or mobile device management, is a protocol that's built into iOS and OS X that allows the server to remotely manage the device. And the MDM server can install network access, install accounts, email and calendar, install books, and install and configure apps. We're familiar with that, but with iOS 8 along with MDM, apps can also install extensions, in keyboards and document providers, as we mentioned earlier. So with MDM, iOS restricts the data flow between managed app and other apps. In other words, it controls the data flow, meaning the managed apps cannot access personal information, mails, and extensions. Thus, MDM ensures security by separating user data and enterprise data. Yay. MDM managed devices are called super voice devices. owned by the enterprise via device enrollment program and can be pre-configured with the device with necessary applications for the device and the restrictions prevent app uninstallations, for instance, and allows and always on VPN or remote monitoring and all these kinds of things you might want for enterprise access or management. Supervised devices can be configured with a single app mode where a device can be locked into just an app by MDM. Perfect, for instance, for like a kiosk type use, which is, one use type app for the device. MDM pushes configuration to the devices and changes the configuration over time. This configuration may include URL docs, server root certificates, which apps can be used for single sign-on. Configuration can also be we push server trusted certificates, which is nice, which apps can use for server trust evaluation by certificate pinning is also provided by that MDM configuration push. Newly introduced document providers allows the app to exchange documents between the apps, as we talked about. MDM can leverage these document providers to provide access to enterprise network resources, allowing the enterprise users to access those documents securely. Autonomous single app mode is the MDM capability for supervised devices, which lets an app push itself into a single app mode. Thus, the app can take control over the iPad to lock itself in. In other words, exams as an education app. So what about Android for work? Well, there's a fairly simple slide here with the key points. But again, I'm going to narrate you through kind of a longer description of what's up with this. If you've bemoaned the inability to use your personal Android phone for company business, which a lot of us have, Google has some heartening news now. It's just unveiled that Android for Work, a code platform that lets your business and your personal info coexist on a single device. An enterprise drive for Google, finally. In the past, Google has largely left the task of customizing Android for Work to others, both device makers and third-party software companies such as Good Technology and AirWatch. However, now part of Samsung Knox, K-N-O-X, will be integrated into upcoming Android L platform, which is powered by a containerized Android for Work solution. And this technology keeps the data types separate without requiring any changes to existing apps. From what we are seeing, Google has their own containerized technology in Android L, and this is similar to Samsung Knox, but it's not Knox and will essentially have to prove itself yet again. It's also much more limited in features than the current Knox solution and quite a bit behind the competition when it was released. So every major Android manufacturer should have Android for Work certification in the fall, with promises of both guaranteed updates and full security. The Office-friendly feature is baked into Android L release from the start, but don't despair if you're toting an older device. Google is promising an app for that works on Android gadgets running Ice Cream Sandwich or later. Cool. Enterprise can set up a work profile for the user and will be enabled once the device comes into Wi-Fi vicinity. Everything will be presented in a unified view on the home screen, in the recent app list, and in the notification view, thus avoiding the often maligned approach of having two completely separate environments. And what a pain that is. With regards to bulk distribution, businesses can use Google Play to bulk distribute apps to everyone in a company, a specific group of users, or just to certain individuals. The Group Play private channel for Google Apps, the private channel, allows Google App domains to distribute their internal Android application to their users through the Google Play Store. Bob Egan, by the way, over at Forbes, theorizes that Google is trying to help Samsung save face after the lackluster traction gem Samsung received for Knox. All right, this is my last slide before I give you to our technical team at Tech Endeavour, and I'm going to just summarize some of the common aspects of enterprise possibilities between Apple and Google. Number one would be using cloud. An enterprise can host corporate data, huge data, sort of public to all of its users or its employees. Using Apple MDM, an enterprise can manage and configure devices, accounts, and apps. And security-wise, controlled data flow between the enterprise apps or your managed apps and the personal apps with bring your own devices. It's all now possible. And this includes secure file download in transit and on cloud encryption. So on the topic of security, let's take something like a healthcare app or school app, which handles critical confidential data. Those things could leverage Touch ID capabilities for user authentication or authorization to enable access to specific app's contents. So the fourth one, single app mode, that would be something like a typical kiosk app where devices are dedicated to let the user use the app in just that one app. iOS 8, autonomous single app mode is available, and the app disables all other device features, including the home button, for instance, during certain actions. All right, so I hope you found that interesting. Now I'm going to give you to our Tech Endeavour technical team, and they're going to go over some topics in greater detail. Then we're going to have the question and answers, so keep sending those in via the chat window, and we'll be answering as many as we can at the end of the event here.
Thank you, Tom. My name is Maitri, and I'm going to explain about the use cases for a possible solution of iOS 8 for typical use cases on Salesforce Enterprise. So in this slide, you can see that the Sales Enterprise can publish the data to Salesforce with the CloudKit. This might include data like task list, product hierarchy, and inventory details, etc. Enterprise can then view and publish the data applicable to the sales hierarchy using CloudKit dashboard. Along with the above-mentioned structural data, Enterprise can also publish public documents via iCloud document storage and manage access to the sales team. For example, these documents may include product brochures, demo videos, and product manuals, and etc. On iOS device, sales personnel can log into the application using Touch ID. With the CloudKit integration integrated into the mobile app, sales representative can seamlessly access the public data published by the enterprise. Sales representatives can also access enterprise documents using document providers. As we have already seen, with the document provider, iOS app can access those documents available outside the sandbox securely using doc provider extension. With this, app can import the network resources inside the application and can even use other apps to view or update the documents and upload it back to the enterprise server. If the enterprise hosts documents using iCloud document storage, apps get the downloaded documents seamlessly synced whenever there is an update available on the server. Sales personnel can participate in survey by importing survey forms published by the enterprise using document providers. Salesperson can fill in the form and upload it back to the enterprise cloud to participate in the survey. Enterprise can restrict the location-sensitive operations for sales personnel by using region monitoring or geofencing or even beacon-enabled region monitoring. Example, scanning the products in an inventory or product checkout can be restrained to be monitored in a secluded area by the enterprise. And with all these possibilities, the application can even be more secure by using or leveraging Apple MDM capabilities.
Thanks, Maitri. So I'm Basavaraj. I'm going to give the use case with Android L. Let's explore the use case with Android L, which has introduced many enterprise features like task locking in Google I/O. By introducing task locking, Google is setting up Android to become contender in many markets like self-service kiosk. This market is dominated by a special variant of Windows CE. Android L developer preview introduces new task locking API, which restricts users from using any other apps or viewing other notifications. This could be used for sales and marketing services. For example, retailer can develop marketing app which can display the marketing content without interference from other apps running on the device. On the kiosk mode, device will not receive any notifications from any apps until it exits the kiosk mode. Another use case will be like educational case, like you are taking the legal exams or medical exams on phone. That time this can be used.
Thanks, Basaraj and Maitri and Tom for giving us very thoughtful insights into iOS 8 and Android L. As you might have seen, there are more than 4,000 APIs into iOS 8 and more than 5,000 APIs into Android L that are coming into the latest versions that you would see sometime in the fall. There ought to be a lot of changes that you would expect onto the application. And to help over these changes into Android as well as iOS application services, Endeavour has launched a new service for application migration, which will help you understand the impact on your existing application for all these APIs that are getting newly added into these upcoming operating system versions, as well as helping you understand what kind of necessary steps that needs to be taken in order to make your application more compliant with iOS 8 and Android L versions. And we can also help you understand what kind of changes that needed to be done in order to match those vertical specific application requirements, may it be healthcare or retail or anything around that. So please feel free to get in touch with us, and we would be more than happy to help you recommend the best strategy to migrate your existing application to the new iOS 8 and Android L operating systems. Now I'm moving to the next slide, which I would like to cover a brief overview of Endeavour's value add and the services that we offer. Endeavour provides services around mobility consulting, mobile UI and UX, as well as mobile application development and mobility integration with a lot of existing solutions in the backend. Through mobility consulting, we help our customers understand the implications of newer operating systems and mobility as such to help migrate from the existing traditional solutions to something that would make fullest use of these operating systems and devices to become mobility first organization. In terms of mobile UX, we have a dedicated team of UI and UX designers who would help you transition your existing applications and build an overall mobile experience that would go well with your existing traditional desktop solutions, mobile solutions, or be it web solutions. In terms of mobile application development, we provide solutions around actual mobile application development, web services. Our experienced engineering team can help you build the solutions through our proven and tested testing and development processes we have. In terms of mobility integration, we have a lot of solutions and services that focus around building the solutions that would help you connect to the wide variety of enterprise information systems that exist into your enterprise today in the backend. We have all these services being provided for past more than a decade, and we bring in all that experience to each of our projects and services that we offer. Thank you. And with this, we hand it over to the next section, which we would like to open it for questions and answers. Over to you, Shreya. Thank you.
Thanks, Avinash. Now we are going to address a couple of questions we have received from the team attendees. So here are the few important questions which we got for iOS 8. So the first question is how iOS 8 app extensions work and how can other apps integrate with my app extensions. So before answering that, we want to understand that an app extension is not an app. Rather, an extension is a separate bundle within your containing app that produces a separate binary. So a host app means other apps using your extension defines the context within which an extension lives and kicks off the extension lifecycle when it sends a request in response to a user action. Shortly after the extension performs its task, the system terminates that extension. So behind the scenes, the system uses inter-process communication to ensure that the host app and an extension can work together to enable a cohesive experience. In your code, you never have to think about this underlying communication mechanism because you use the higher level APIs provided by the extension point and the system. So there is another question on extensions. Question goes like this: how to create extensions and how do I distribute it to App Store? So using Xcode, before creating the extension, we have to decide which type of extension point we need to support in the application. So available types are share, custom action, storage provider, today custom keyboard and photo editing. So with Xcode, you can use the template for creating an extension point you want to choose and enhance the default files with your custom code and custom user interface if required. After implementing that functionality, you can distribute it within your app, within your containing app to the App Store. Other question is like, what is the difference between single app mode and autonomous single app mode? The main purpose of both the approaches aim to constrain the device or user to use only one of your app on the device. In single app mode, the server locks the device to run only your app, whereas in autonomous single app mode, the app can lock itself, means user himself into the application during some critical operations, and can later exit out of the single app mode. Indeed, both of these are possible only with MDM supervised devices, and in case of autonomous single app mode, the app needs to be pre-authorized by MDM server. Other question is, how can an enterprise provide access to corporate documents? So the answer is, to provide access to corporate documents can be done using document provider extension, which would enable apps to provide access to the documents outside the app sandbox. A document provider's file provider extension can be configured with any third-party host, or alternatively, an app can enable iCloud document storage and set the access to app's public container. Document provider also facilitates user authentication mechanism to manage document access. There is another question on HealthKit. So the question goes like this: with HealthKit, how can an app observe and get notified and gracefully handle users' permission to share or access health data to and from health store? To do that, there are 3 steps. In first step, we need to understand that iPad doesn't support HealthKit. Hence, application should first check if HealthKit is supported on any iOS device. And the second step is, application should request health store authorization APIs for read and share access for different types of data sets. So on first launch, application would present a dialog where user can set his permissions accordingly, read and write for each type of data set. User's response to write access is accessible by the app. However, reading authorization response is not revealed to application to govern user's privacy. Additionally, app can check for authorization status for given type of data over the period of time.
Okay, first question is whether Android Wear devices can be used for Google Fit platform to record or monitor the health parameters. Answer is, of course, Google Wear is built to provide lot of services to the users, and Google Fit is one among the services in the market. These devices have inbuilt health sensors to collect data based on various health parameters and send those details to Google Fit platform via connected smartphone. So application running on the device gathers the information and generates reports. Second question is, can I apply material design for apps running on older version? Answer is no. Material design is available only in Android L preview. Alternately, you can configure your app such a way that it will use material design theme on Android L preview versions, whereas it will use older themes on older versions. Next question is whether Android Auto includes any of the features from Google's driverless car system. So answer is like, as of now, Google has distanced itself from driverless car system, but however, we predict Google might bring both the frameworks together and build smart auto system in future. Next question is, can I use task locking or kiosk mode in my Android application? Answer is like, developers must have authorized access to use this mode, and this authorization must be granted by specially configured device owner app to use this API. So basically, like, this mode is available for enterprise apps only. Next question is, can we run existing application on Android L? If yes, can you provide prerequisites or guidelines for app migration? Answer is yes, you can run your existing app on Android L preview without any changes. However, if you want to leverage newly introduced material design, then definitely you need to do changes in your application, like using the new theme for your screens, or using new widget controls, or using new animation classes, and so on. More detailed information will be available on our website after this webinar.
We were not able to answer all your questions due to lack of time today. but you can soon expect detailed answers to your questions in your mailbox. Please feel free to reach out to us at info@techendeavour.com for any more details. The webinar recording will be made available on techendeavour.com/webinar within the next 2 days. We would also be sending you an email notification with the webinar recording link. I would like to extend my gratitude to Tom and our technology panelists for taking us through the webinar. Last but not the least, I would also like to thank all the attendees without whom this webinar would not have been such a success. We hope you also found this session valuable. We appreciate your time and hope to see you at the forthcoming webinars. Have a good day.